All right, grab a marker and let's map this whole thing out right now. For this explainer, we are literally turning this massive, totally blank whiteboard canvas into a living, breathing, high-speed blueprint of how tracking actually works. So let's just dive right in. How does a device know where it is? Bam, I'm throwing a giant, bold question mark right in the center of the board. Think about it for a second. Our devices, they don't have eyes, right? They can't just look around at buildings or street signs to figure out where they're standing. They somehow have to pull their location out of incredibly thin air. Finding the invisible dot. Starting with a blank canvas, let's keep the marker moving. I'm sketching out a tiny device totally lost in this infinite sea of blank white space. It's completely blind, and it desperately needs some kind of reference point to anchor itself. Location is invisible. I'm furiously scribbling the word invisible in bright red ink right next to our device. Because, we humans can easily look out and see our physical surroundings. But to a machine, location doesn't physically exist to be looked at. It means a completely different way to make sense of the world. Location is inferred. Watch this. I'm striking a thick line right through that red word and underneath writing inferred in glowing neon green. We are shifting gears entirely here. We aren't seeing where we are actively calculating it, based on hidden clues just bouncing around the atmosphere. Inference is turning uncertainty into a specific point by comparing weak signals against a known reference. Let's box this definition in brilliant blue ink because this is the golden rule for our entire living map. We're grabbing pure, chaotic uncertainty and morphing it into a precise, mathematically locked-in dot. Turning time into distance, the speed of light. Let's splash some bright yellow right across the board here, a massive lightning bolt. Because now we are launching straight into the actual physics of how timing literally creates physical space. Geography versus timing. Let's split the canvas right down the middle. I'm sketching a standard map on the left and a frantically ticking stopwatch on the right. Think of thunder and lightning. You see the flash, you wait for the boom. The sound didn't just vanish, it took time to cross the gap. That delay is exactly what reveals the distance. Here are the 3 irreducible truths. Rapid-fire bullet points coming in. 1. Signals carry a timestamp. 2. Radio waves travel at a known speed. 3. Delay equals distance. Meaning if your internal stopwatch is even a tiny fraction of a second off, you get a massive location error, because we are measuring things moving at the literal speed of light. Overlapping signals reveal position, drawing the boundaries. Let's wipe that side of the board completely clean and slam down a single solid black dot. That's a transmitter way up in space. So what happens when we take that lightning-fast time delay and use it to draw a physical boundary around ourselves? One signal equals a massive, vague circle. I'm sweeping a gigantic, kind of imperfect circle across the canvas. One signal alone just tells you you're somewhere on this huge line. It's like having a single dim ceiling light in a massive dark room. Sure, it casts a shadow, but it's totally unhelpful for finding an exact spot. 2 signals equals overlapping boundaries. Watch how this builds. I'm throwing a second overlapping circle onto the board. See how they intersect right there? Suddenly, our endless possibilities shrink down to a much smaller, manageable zone. We're getting so much closer. 3 signals equals the invisible dot. Bam! I'm jamming a neon red marker right into that tiny space where a 3rd circle overlaps. We just trapped it. We've triumphantly calculated a single physical coordinate out of pure radio wave delays. The invisible dot is officially found. A torn receipt does not tell you the whole story from one piece, but if you line up the fragments carefully, the missing shape becomes visible. I'm quickly scribbling fragments of torn paper around our red dot here. Your receiver isn't just passively listening to a broadcast. It's an active detective, painstakingly piecing together these incredibly weak, fragmented clues from space to make a solid shape appear. Connecting points into paths, adding the dimension of time. Let's rip a fast, aggressive arrow pointing straight to the right side of the board. Finding one dot just isn't enough, right? A single location is static. We have to string these dots together at high speed to actually catch a moving target. 0 seconds, 0.1. 5 seconds, 0.2, 10 seconds, 0.3. The result is a track. Look at this. I'm connecting a rapid series of dots with a thick, bold purple line. Injecting the dimension of time magically transforms an isolated point into a fluid, dynamic path, zooming across our canvas. Real-world state versus system output. Over on the left side, I'm sketching a messy, erratic zigzag. That is the real world. It's bumpy, it's noisy, it's chaotic. But on the right, a perfectly smooth, beautiful, filtered line. This proves that a track is really just a cleaned-up model of reality. The system is actively sculpting what happened. Filtering the messy noise. What counts as a real change? Watch this. I'm literally taking my thumb and smudging that beautiful, clean line we just drew. That smudge, that's interference, weak signals, bouncing radio waves. The critical question our living map has to answer right now is, did the object actually physically move, or did the signal just glitch out? Making the cut. Is it a real 2-meter move? Is the signal strong? Is it just noise? Let's drop a series of rapid-fire green check marks down the side. The device is desperately trying to hear a delicate little melody inside a wildly noisy room. It constantly has to ask, which of these notes do I actually trust enough to draw the next piece of the line? The map is a model of movement, not the movement itself. I am circling this text 3 times in blazing orange marker. 1, 2, 3. That smooth line gliding across your screen is an interpreted, highly edited story. It is not raw, unfiltered reality. The machine is making incredibly complex choices for you behind the scenes. Building the movement model, turning location into history. Let's step all the way back from the board, revealing the grand, chaotic architecture we've been building this whole time. I'm outlining a generic delivery truck weaving its way through a bustling city. We aren't just looking at solitary coordinates anymore. We are tracking a living history. The blueprint pipeline. Step 1, signal timing. Step 2, receiver distance. Step 3, rapid sampling. Step 4, interpretation to create a filtered track. I'm dragging a giant neon flowchart right across the whole canvas, connecting everything with massive arrows. We're literally watching raw, invisible evidence evolve into a completely usable movement history right before our eyes. Let's draft a quick, highly structured grid right here in the corner to lock this in. Level and identity. Our single, invisible location point is the atom. The connected track is the molecule, and the repeated route pattern, that's the entire complex structure. What started as a tiny timing delay in space has exploded into a massive operational tool for tracking entire fleets and logistics. Signals to timing, to distance, to position, to movement. I'm rapidly underlining each word with a thick black marker as we sprint through the ultimate logic chain. Signals become timing. Timing becomes distance. Distance becomes position. Position becomes movement. We are capping off this entire chaotic drawing process in one single massive breath. Now that you know the map is just a filtered model of reality, what hidden details is your smooth digital track choosing to erase? I'm dropping the marker. Just stepping back from the whiteboard to look at this absolute masterpiece of a living map. Think about the device in your pocket right now. Knowing that the beautifully smooth digital track mapping your day is just an edited model, what hidden, messy details is your map constantly choosing to erase?